The quarry run by Montana Limestone Company sells about 760,000 tons of limestone every year. With new customers coming on board, Dakota Coal and Montana Limestone manager Dean Bray knew the efficiency of the blasting process could be improved. Jacob Dow, Dakota Coal Engineer 2, describes the project to optimize blasting procedures at the quarry.
So one of the first things is getting the proper hole placement in regards to the face. So profiling is really important to get detailed measurements. The other thing is having a straight borehole that you're blasting with. And so we got a tool to be able to measure how straight the holes are, and that was pretty enlightening to see the poor quality of holes that we were getting at the quarry. So once you get your profiling and your boreholes straight, then you look at being consistent with the bulk explosive that you're using and the timing that you're using from hole to hole and row to row to get good fragmentation results. If the holes aren't straight and they wander away from each other, you're going to have low energy in that area, and so the fragmentation is going to be poor, resulting in oversized material. If they wander too close together, then you've got high energy, which is a safety risk. You can have fly rock and things like that, as well as very small fragmentation sizes, resulting in a lot of fines material, which isn't exactly something you need to keep in check. If you have too much of it, we don't have a home for it, so then it's considered a waste. Yeah, so if the muck pile is too tall when you're done, it becomes a safety concern at some point to the loader if it's 2 or 3 times the height of his machine. And so then we were having to spend quite a bit of time with the dozer on top of the shot, knocking it down so it was safe and be able to load out. And that adds a lot of man hours to the process as well. We were all very anxious to see it go, and then having that viewpoint with the drone recording the shot was excellent to be able to see it at a good angle and up close while still being at a safe distance away. So it was really good, because otherwise you can't really be very close to them for obvious reasons, but the drone helped out a lot to get a good view of what's going on and how things progress through the shot, and can be used to analyze and look for problems that occurred and things like that.
The next steps in the optimization process include monitoring production performance, fine-tuning the blast pattern, and making one change at a time to monitor progress.